Hi students, welcome to lecture number 9, that is advantages and disadvantages of finite element method. Okay. Perhaps everybody knows every material world, everything there is some advantages and disadvantages. In the similar way, FEM is also finite element method is also having some disadvantages as well as some advantages. We can see here one of the major advantages of FEM over approximate methods is that FEM can handle irregular geometry in a convenient manner. Okay, by using FEM we can solve the plate with hole. Okay, plate with hole, we can solve this kind of problems also. Okay, in mechanical students they will get this kind of problems, plate with hole, thin plate with hole, then we have to apply some forces, then you will get the stresses and principal stresses, principal strains, everything by using this FEM. So this FEM can handle irregular shapes also, like this you can see here, this kind of shapes also we can solve by using this finite element methods. Okay, over other approximate methods. Okay, then you can say it second advantage is it handles general loading conditions without difficulty. Okay, it can handle any loading conditions, like a UDL, UVL increasing decreasing. Okay, UVL increasing decreasing, point load or couple movement, everything whatever loading conditions will handle this finite element method very easily. Then coming to non-homogeneous materials can be handled easily. Okay, non-homogeneous materials also we can solve very easily by using this finite element method. Okay, what is non-homogeneous? Non-homogeneous materials is nothing but the properties is not different, or not same. The properties of the materials are having more than one property, then that material is called the homogeneous materials. Okay, then fourth advantage is all the type of boundary conditions are handled. Any type boundary conditions, that is nothing but let us say it is a simple supported beam. What is the boundary conditions of this simple supported beam? The boundary conditions of this simple supported beam is at support, at simply support, deflection is 0 and slope is something, slope is let us say 30 degrees, something like that. These are all these are the boundary conditions. Okay, boundary conditions. So any type of boundary conditions this FEM can handle very easily, so that the FEM is used highly in by in developing the softwares like STAD, tabs and everything. Okay, because this is one of the criteria, that is all types of boundary conditions are handled. Okay, dynamic effects are also included, it is very important. Okay, I will tell you what is dynamic and statics. You can see here, statics already we have studied only statics, but dynamics is somewhat interesting. You can, statics is nothing but if you apply the load on the some particular beam, means the load will not change, the load is constant. Then we have to find the reactions of the beam and bending moment and everything. But in dynamics, the load is changing with respect to time. Okay, the load is changing with respect to time. Okay, these kind of problems are nothing but dynamic problems. The examples of these dynamics are vibrations of the structures, vibrations of the structure, or vibrations of the machines. Another example is earthquake vibrations. Okay, earthquake vibrations, because in the earthquake, at each and every point the acceleration of the force will change. At each and every point the acceleration and or force will be changed. Okay, force is nothing but F is equal to ma. Okay, see, you can see here in during earthquakes or something, we can see in a TV, you can see here accelegrams, means the graph will be look like that, like this, like this. Okay, perhaps you have seen this kind of graphs. Okay, this is a earthquake acceleration graph. Okay, see these kind of problems also very easily handled by this finite element method. Finite element method. Okay, so dynamics effects are also included. Then vary the size of elements to make it possible for smaller elements where necessary. We can vary the size of elements to make it possible for small elements were necessary. Okay, this is sixth advantage. Then higher order elements may be implemented. We can implement higher order elements. Okay, higher order elements. Then eighth one is altering the element model with different loads, boundary conditions, and other changes in the model can be done very easily and cheaply. What is this mean? What is this mean is we can easily alter the different loads. Okay, let us say if you have P is equal to 10 kilonewton, then we can easily alter we can replace the 10 with 100 kilonewton. We can easily alter the boundary conditions also. Let us say you can alter the fixed to simple supported, like that, and other changes in the model. We can also make the homogeneous to non-homogeneous to homogeneous very easily and cheaply. Okay, but we have to write these all these in programming. We have to write the codes in any of the modern or traditional programming languages. Okay, okay, these are some of the advantages of finite element method. Okay, finite element methods. Then coming to, as usual, disadvantages of this FEMR. It requires digital computer and fairly extensive software. Okay, mostly these FEM softwares are proprietary softwares. Okay, proprietary proprietary softwares. Proprietary softwares means we have to purchase. This is not a open source for software which will available freely. No, these FEM softwares are examples are as far as our civil engineering STAD, STAD ETAPS. Okay, SAP 2000 and ANSYS also, ANSYS analysis systems, ANSYS, and also NASTRUN. Okay, NASTRUN. Okay, these are some of the. So it requires digital computer and fairly extensive software. Okay, it requires longer execution time compared with finite difference method. Okay, what is the disadvantage? It requires longer time to execute. Okay, longer time to execute with finite difference method. Okay, while you are solving some problems, earthquake problems in SAP or ETAPS and STAT, it takes lot of time to execute the program, to execute the problem. You can see output result will vary considerably when the body is modeled with fine mesh when compared to body with coarse mesh. What is mean by this is, I will show you an example. Let us take a bar element. 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 If you divide the bar into number of parts, more number of parts, then we'll get the exact value. Exact value. If the same bar is divided into less number of parts, then we will get approximate value, only at the approximate value. But we want to get this exact value, but the stiffness matrix will be increased. Let us say how many parts is there. 1 2 3 4 5 6. In this example, 6 by 6 matrix will come here. The stiffness matrix is 1 2 3 4. 4 by 4 matrix will come. 6 by 6, so 4 by 4, 6 by 6 is a very huge matrix, so it takes lot of time by computer to solve this kind of problems. But we'll get the exact value, that is different thing. But as far as time concerned, it takes more execution time when the mesh is nothing but dividing the parts. When the mesh is When the mesh is having lot of parts, then it will take lot of time, but we will get the exact value. And if mesh is not closely spaced, that is the mesh is not divided into lot of parts, then we'll get the approximate solutions, but with a very less time. Okay, that is the meaning of this output results may considerably vary when the body is modeled with fine mesh when compared to the coarse mesh. Okay, in finite difference method, the governing differential equation of the phenomena must be known, whereas finite element method does not require to express fully. Okay, this is also one of the disadvantage of this FEM. Okay, I hope everybody understood this. Okay, very easy. Okay, while you are solving problems, then you will get what is the advantages and disadvantages of this finite element method. But you have to solve those problems in computer, otherwise you cannot get. Okay, what is this advantages and disadvantages? Okay. Okay. Anyway, thank you for watching this video. Thank you.